Hi guys, let's look at the next question. The next question is question 7. But again, before we start, let's quickly revise the formula of this exercise, which is small v upon capital V is equal to density of solid upon density of liquid in which it is floating. Small v is volume under liquid when it's floating. Capital V is volume of solid, and density of solid and density of liquid is self-explanatory. So let's look at the question and see how it works. So question number 7, it says a wooden block floats in water with 2/3 of its volume submerged. So let total volume is equal to V centimeter cube. Next, 2/3 of it is submerged. Therefore, small v, which is volume under water, is equal to 2/3 of v centimeter cube. Correct? So v upon v we know is 2/3. Calculate the density of wood. So small v upon capital V is equal to density of wood upon density of water. Small v is 2/3 V upon capital V is equal to density of wood upon 1, which means V and V gets cancelled, which means density of wood is equal to 2/3 gram per centimeter cube, or 0. That will be 66667 gram per centimeter cube, which will also be equal to 666.7 kilogram per meter cube. So that's the first part of the question, which is calculate the density of wood. Next part of the question, it says when the same block is placed in oil, 3/4 of its volume is immersed in oil. So in oil, small v is equal to 3/4 of capital V. Calculate the density of oil. So we know small v upon capital V is equal to density of wood upon density of oil. Small v upon capital V is 3/4 is equal to density of wood. We just calculated density of wood as 2/3 upon density of oil, which means density of oil will be equal to 2/3 into 4/3. So that's 8 upon 9. Therefore, density of oil would be equal to 9 into 8. That will be 72. So sorry, 0.8. Again 8. So this will be 8889 gram per centimeter cube. If you want to write it in kilogram per meter cube, it will be 888.9 kg per meter. I hope you realize how simple these questions are. Only one formula, small v upon capital V is equal to density of solid upon density of liquid. What you need to keep in mind is small v is density under the liquid, capital V is the total volume of the solid. Let's look at the next question. The next question that we do is question number 8. Question number 8 says density of ice is 0.92 gram per centimeter cube. So density of ice is equal to 0.92 gram per centimeter cube. That of seawater, so density of, we've done a question like this where we figured out how much is underwater. Let's look at this, 1.025 gram per centimeter cube. Find the total volume of an iceberg which floats with its volume 800 centimeter cube above water. So please keep this in mind, this is above water. So let total volume of iceberg be capital V centimeter cube. Let volume under water be small v centimeter cube. So what's given is so what we know is volume, therefore volume above water is equal to capital V minus small v, which is volume, total volume minus the volume which is underwater, and this is given equal to 800 centimeter cube. Correct, that's what's given. Yes, and volume underwater will be equal to capital V minus 800 centimeter cube. Total volume minus volume which is already above water. In case you want to understand this with the help of a diagram, so this volume here, which I am marking with red color, is 800 centimeter cube. The total volume is V. This volume is V minus 800. We can also write it as small v. Yeah, and this volume is capital V minus small v, which is 800. That's for our understanding. Now let's apply it in the formula. Small v upon capital V is equal to density of ice upon density of seawater. Small v is equal to capital V minus 800. Capital V is equal to 0.92 upon 1.025. Now we'll cross multiply. It will be 1.025 V minus 800 into 1.025 is equal to 0.92 V. Okay, let me erase this diagram. One second, let me just place it somewhere else in case we still need to refer to it slightly later. Perfect. Let's see if we can still solve it within the area which I have left. So that will be 1.025 V minus 0.92 V is equal to 800 into 1.025. Let's do the calculation. 1.025 minus 0.92. That's 5, 2 minus 2, 0. That's 10 minus 9, 1. That's 0.105. 0.105 V will be equal to, now I need to multiply. So the multiplication is 1025 multiplied with 8. Right? 1025 multiplied with 8. 5 into 8, 40. 8 into 2, 16 plus 4, 20. That's 2. And this is 8. Let's just reconfirm. Yes, this is fine. So this is 8200. I have 3 decimals and 2 more. So this will be 820. Yes, so I go 3 decimal, that's 1, 2, 3, and I go 2 decimal ahead because there are 2 zeros. This will be 820.0. Therefore, capital V would be equal to 820 upon 0.105. That's 820 into 1000 upon 105. That's 5 into 21. That's 5 into 1, 5, 32. That's 5 into 6, 30, and 4. Let's divide. So this would be 164 upon 21. That's 21 into 7. That's 7, 147. 14 minus 7, 7. 5 minus 4, 1. 0. That's decimal. So 21 into 8, 168. Correct? That's 20. So that's a 0. 200. That's 21 into 9. Yes, that'll be 9, 189. So that leaves 11, which means a 0, which means 21 into 5. That's 105. That leaves 52. I think I have done enough number of decimals. Therefore, V would be equal to, I multiply it with 1000, so that's 123. So 7809.52 centimeter. So that's the total volume of the iceberg. Interesting question. What I want you to remember is that you need to read the question and figure out what volume is given. In this case, this volume was above water. Good. This brings me to the last question of this exercise. The last question, which is question number 9, slightly longish question. So let's read it. It says a weather forecasting plastic balloon of volume 15 meter cube contains hydrogen of some density. So the volume of hydrogen is 15 meter cube. Perfect. Volume of an equipment carried by the balloon is negligible compared to its own volume. The mass of empty balloon is 7.15 kg. Balloon is floating in air. That's also fine. Calculate mass of hydrogen in the balloon. So mass of hydrogen. So before that, the only formula we know is density of hydrogen would be equal to mass upon volume. So density of hydrogen is given equal to 0.09 kg per meter cube, which means mass of hydrogen would be equal to density into volume, in this case 0.09 kg per meter cube multiplied with volume, which is 15 meter cube. So the mass will be equal to 0.09 into 15, that's 15 into 9, 135, with 2 zeros gone, which means 1.35 kg. So simple formula, density is equal to mass upon volume, gives us the first part of the question. So mass of hydrogen done. The mass of hydrogen and balloon. Okay, so mass of hydrogen plus balloon. Mass of balloon is already known. Mass of hydrogen we just calculated. So it will be 1.35 kg plus mass of balloon is given as 7.15 kg. So 7.15 kg. So 7 plus 1, 8 and 5. That's 8.50 kg. The second part of the question also done. Let's look at the third part of the question. Third part of the question says total mass of hydrogen balloon, which we've already calculated, and equipment. But equipment weight is not given. If the mass of equipment is x kg, okay, therefore mass of hydrogen plus balloon plus equipment would be equal to 8.50 plus x kg. This we'd already calculated in point number 2, so all we need to do is just add x to it. Done. So part 3 of the question also done. Let's look at part 4. Part 4 says the mass of air displaced by the balloon. So the volume of air displaced by the balloon is 15 meter cube. We need to find the mass of air displaced. Okay. So mass of air displaced would be equal to upthrust, would also be equal to, the formula would be density of air into volume. So density of air into volume. Exactly the same formula, mass is equal to density into volume. In this case, density of air. The density of air is given as 1.3 kg per meter cube, and the total volume of this substance is 15 kg. Not 15, 8.5. Sorry, not 15, 8.5. Why 8.5? We need to calculate volume. Why am I looking at mass? The volume is 15 meter cube. Right? The volume is 15 meter cube. So that's 1.3 into 15 meter cube. That's volume. I got confused. This is not volume, this is the mass. So the volume is 15 meter cube, which means 1.3 into 15. That's 150 and 45. That means 195. How many decimals? 1. That's 119.5 kg. So mass of air displaced is density into volume. Density of air is 1.3, and the volume which is being displaced is equal to the volume of the balloon, which is 15 meter cube. Last part of the question. Last part of the question says mass of equipment using the law of flotation. So since it's floating, so when an object floats, we know that the weight is equal to the mass of air displaced or equal to the upthrust. So when an object floats, mass is equal to upthrust. So let's substitute values. We know mass is equal to 8.5 plus x. This is including the weight of the equipment. Upthrust we know is 19.5, which means x is equal to 19.5 minus 8.5. Therefore, x is equal to 11 kg. So, mass of equipment is 11 kg. I hope you like the video. I hope you also like the way I have done the question. If you have any queries, feel free to write to me. Meanwhile, take care, be safe. I'll see you with the next video. Bye bye.